A population of elk, excuse me, I don't know, my throat's driving me crazy. Population of elk oscillates 150 above and below the average of 720 during the year, hitting the lowest value in January, which is t equals 0. So to do part A, we need to find an equation for the population P in terms of the months since January. Okay, so I'm just going to sketch a little graph here of what's happening, or what the problem's telling me at least. So January is here at t equals 0. That means February is going to be t equal 1, March is going to be t equal 2, etc. We want to do a whole year, so January is also here at t equal 12. Now, my midline is at 720 because that says that's the average during the year. And it oscillates 150 above and below. So 720 plus 150 is this high point, and 720 minus 150 is the low point. So let's see. There they are. 720 plus 150 is 870. And 720 minus 150 is 570. All right, so I have a low point here and a low point here. And since it's a sinusoidal graph, I'm going to assume that the high point happens right smack dab in the center. Now, the weirdest part is what month that is. I mean, if January equals 0, this is still the 6th month, but it turns out to be July because I'm counting January as 0. That means February is 1, March is 2, etc., which puts July at t equals 6. And my nice, lovely graph will look something like this. Here's my midline right there. All right, so again, when I do these, my models, I need an amplitude, I need a midline, I need a period, and I need a horizontal shift. Now here, because I'm starting at a low point on the axes, this is going to be a regular cosine graph, so there isn't going to be a horizontal shift in this part. The amplitude is a distance from the midline to the top, which the problem said was 150. The midline is the average, which is 720. And the period is 12 months. So now, again, my model is going to y equals a cosine bx plus d. And I'm using cosine because I'm starting at the low end. When you start at high or low on the axis, it's a cosine graph because the regular cosine of x graphs does that. Or in this case, minus cosine of x, because it is turned over from regular cosine. If you're taking a test or something and you can't figure it out, just graph the original sine and cosine graph over one period. And then whichever shape it most mimics, that's what you want to use. So I need to find a, b, and d. So a, actually in our case, is minus 150 because it's 150 because the amplitude is 150, but it's negative because this is an upside down cosine graph reflected over the midline. My d value is 720 where the midline is, and my b value is going to be 2 pi divided by my period, which is equal to pi over 6. So putting my model in here, that's going to be y equals minus 150 cosine pi over 6x plus 720. Now, if I put that data in my stat menu, now I know you guys don't like to do this, but it's not that hard once you get used to it. I go to my little stat menu, and I'm just going to put these points in there. So when I'm at 0, I'm at 570. When I'm at 6, when I'm at 6 here, when x is 6, y is 870. And when x is 12, y is back up at, back down to 570. So I create my window the same way. I'm going to go from 0 to 14, which is just a little past 12. Well, let's just do 12. That'll be easier here. And then my y min is 0 because I like to see the axes. And I'm going to do 900 as my max because that's slightly bigger than 870. And go to my stat plot, make sure it's on, which it is. And it's a scatter plot with using list 1 as x and list 2 for y. And it's a little square. That's on. So it should graph it just nicely. So there's my 3 points. And I always got to remember to clear this guy out. What I really want to put here is the equation that I got in my problem. So let's put it in. Minus 150 cosine pi divided by 6 x plus 720. And hopefully it'll go through all the dots we want. Oh, look at that. That's nice. So that's part A. Now part B. What if the lowest value of the rabbit population occurred in March instead? So now instead of being in January, it's going to be in March, which is t equal 2, which is now shifting all the points to the right 2 units. So everything is going to stay the same except for instead of having no horizontal shift, my horizontal shift now, let me put a line here to divide this. My horizontal shift now is going to be 2 units to the right. Everything else stays the same, except for now I have a horizontal shift 2 units to the right. Now, in general, when you deal with a horizontal shift, that's y equals a cosine bx plus c over b plus d. Now, this number right here is your horizontal shift. Always. That number, c over b, is your horizontal shift. So if my horizontal shift is 2 units right, that means c over b is going to equal negative 2. Right for negative and 2 units to the right. So using the same a, b, and d, I just fill in the parts to this equation. So y equals minus 150 pi over 6 x minus 2 plus 720. So all I did was add a right moving shift in here. So let's go back up to my data, or back to the calculator's data. Let's do that. And we're going to change it a little bit to make sure I did this right. So go to my edit. And now the low point, instead of being at 0, it's going to be at 2. And I'm going to add 2 values to every point here because everything is being shifted right 2 units. Regular output shifted right 2 units. And I'm going to stretch my window a little bit to 14. So I get all the points in there. So clear this guy out. Come on, you can do it. I need to clear him. Clear. And then there's my 3 points. See, it starts in March at the low point. Now, let's put in the equation that I got. Minus 150 cosine pi divided by 6 x minus 2 for the shift horizontally plus 720. And let's see what happens. Let's hope for the best. Look, it goes right through that point, up to the high point, and down to the low point. So now we have a model where when the elk population is lowest in March, this fits.